And now let's look at the case where we don't want to make the camera movements on set, but we want to shoot with a static camera and add the camera movements later in post-production. This is especially useful in cases of long dolly shots or in situations where we need the camera to be far away from the actor and we wouldn't be able to achieve such distance of the camera in the studio. Unlike the previous method, this will not be a composition of the output from the Unreal Engine, but we will insert the film character directly into the level in Unreal Engine. The character will then function basically as 2D video in the 3D space. The figure has no depth, but if we don't change the camera angle too much, it won't be noticeable to the eye that this is not a 3D object. The camera can be animated, but it's always necessary to remember that the final shot has to be approximately the same angle as it was shot. The huge advantage of this technique is that our real characters, even if they are only two-dimensional, will fully function in the 3D space. They can be covered by other 3D objects, cast shadows, reflect in reflective materials, and react to virtual lights. The disadvantage is that because the shot is only two-dimensional, it's impossible to tell its position in space if they are moving forward or backward. Therefore, this technique only works for characters and objects that don't move in axes towards or away from the camera. This method is the most suitable when you have just one character in the shot. You can end up having more of them in the scene, but then it's best to shoot them separately, as we did, for example, in these videos. We have to think about the fact that we will be able to move forwards and backwards with the virtual camera, but moving up, down and sideways will only be possible to a very limited extent, because it's not possible to change the perspective in a 2D shot. If I want the final shot to be low angle or top shot, I have to shoot it that way. I already showed you how to key out the shot in After Effects. The process will be the same in this case. The only difference will be that we won't create a shadow pass. The real shadows don't work in Unreal, but if I need the character to cast a shadow, there is an option to do this directly in Unreal Engine. Okay, let's open up the level. As you can see, I have this dummy in it. I use this as a reference. I usually do this in pre-production, as I already told you. Thanks to it, I can see what the size and position of the character should be in the environment and also how the scene lights affect my character. I often add some other lights to improve the lighting of my character. In post, I just replace the dummy with the film character in the level. Now, let's see how to insert our live actor into the level. Let's create a video folder. In it, create a new image media source. Open it, choose the path to the pre-keyed sequence and set up desired frame rate. Create a new media texture. In the viewport, click Add Level Sequence. In the sequencer, click plus, track and media track. Click plus and choose your media source. Stretch the track over the entire length of the sequence. Right-click on the actor and select Properties. For media texture, select your media texture. Then set the sequence to the desired frame rate. Open up your texture and scroll in the sequence. You can see that your texture is synchronized with the sequencer. That's good. Add a new plane and adjust its dimensions to the size and position of the person. Create a new material and double-click on it. Set the material domain as translucent and the shading model to unlit. This tells the Unreal Engine that we want the material to be transparent. In this case, the background will be transparent. Unlit means that the material will not react to the light sources in the scene. That's what I want for most cases. Let's drag our video texture into the material window. Now it will be necessary to create a blueprint so we can adjust the color and lighting of the figure in the shot to make it match our scene. First of all, let's add settings of the black level. Add a Rise Black Level by Percentage node and connect it to the texture output. Create a new scalar parameter and call it Black Level. Connect it to the Black Intensity level and set its default value to 1. Then create a saturation correction. Create a desaturation node and connect it. Next, create a multiply. This will be used to control the brightness. Then create a power node to adjust the contrast. And finally another multiply to set the color correction. Now create a constant 3 vector. This will control these parameters. Add one minus node between them, which inverts the value. I want a higher value to be a higher saturation, but the desaturation effect works the other way around. Convert it to the parameter, call it albedo for example, and set RGB values to 1. Then change names of the channels to saturation, brightness, and contrast. Connect saturation to the desaturation node. Connect brightness to slot B of multiply and contrast to slot B of power. Connect the output of the last multiply to emissive color. Create a new constant 3 vector and plug it into slot B of the last multiply. Convert it to the parameter and call it tint. Set the value of RGB to 1. By multiplying the texture by a certain color, we actually change its tint. Here you can already see your character in the material preview. Now connect the alpha channel of the texture to the opacity of the material. This tells the Unreal Engine which parts of the material we want to be transparent. And this is how it should work. Save the material, right-click on your material and select Create Material Instance. Then move this instance to the material slot of the plane. Now we can see our character in the scene, but it's rotated and stretched, so we need to fix that. Using the position and rotation settings, we set the desired size of the character and its position in the level. Double-click on the material instance. Thanks to it, we can now set all the parameters that we scripted in the blueprint, and thanks to it, we can now set up the optimal brightness, contrast, black level, and color. Our dummy serves us as a reference. When we are done, we can hide the dummy. Click on it and in the Details panel find Actor hidden in game. We will adjust the position of our actor to the right place. And that's how we got our actor into the level. Now let's create a camera animation. Click here and then click on Create Camera here. Cine Camera Actor. This will create a new camera for us based on the current viewport. Let's drag this camera into the sequencer. Now let's set the correct exposure. Make sure that you have the viewport exposure set to game settings. With the camera selected, go to the Details panel and search for exposure. Change the metering mode to manual. Using exposure compensation, you can then set the correct exposure. Then you can set the desired sensor size. This is important to achieve desired depth of field. Search for film bag and change it to the sensor size you prefer. I mostly use full-frame DSLR. Now set the focal length. Enter focal into the search and add your focal length. In my case it's 25mm. Now let's set the focus. I want the camera to always be focused on the character. Search for focus and change the focus method to tracking. Click on the dropper icon here and then click on the actor. You can see now when I come closer, the focus stays on the actor and the background gets out of focus. That's what I want. If I want my depth of field to be more shallow or deep, I set this using the aperture parameter. Of course, this will change the exposure too, so I would adjust the exposure settings again. Oh, and I forgot to set up my aspect ratio. So it is to be set in the film back section, simply by adjusting the dimensions of the sensor. Now let's create a simple camera animation. Move the playhead to the beginning of the sequence, move the camera to the starting position and create a keyframe for the camera transform. Move to the end of the sequence and find the end position of the camera. Create another keyframe. Now we have created the camera animation that is synchronized with the movement of the actor. If I add any light source to the scene, you can see that my figure doesn't cast a shadow. This is because the material domain is set to translucent. Although the translucent materials gives us the best quality, it cannot cast shadows or be reflected in other materials. If we want this, it will be necessary to set the material differently. Change the material domain to masked and search for dither. Check the dither opacity mask. Connect the alpha output of the texture to the opacity mask of the material. Save the material and see that now the figure is casting shadows. If we want, it's also possible for our character to receive lights in our level. In that case, we would have to set the material domain as default lit and connect the texture output to the base color slot. But I almost never use this because the geometry of the figure is flat, so the light doesn't behave realistically and it ends up looking fake. So here we have our shot. Let's render it out. I always use a render queue for renders of this type. If you don't see it there like I do, again, it's necessary to turn it on in the plugins. If you have it, click on the flop icon and get into the render settings. There, in the output section, set the output path and resolution. Then click on settings and add anti-aliasing. I already explained how it works. In this case, however, slightly different settings will be required. Check override aliasing. Then set up the anti-aliasing method. If our character's material is in masked mode, I usually use the fast approximate method. I have tested all the methods and this gave me the best results. Temporal anti-aliasing or temporal super resolution looks smoother, but it causes ghosting and it makes the actor look very soft. Most people recommend using the none mode, but in this case our material is masked. Masked material cannot work with semi-transparency, but it uses dithering instead. If we set the anti-aliasing method to none, it would make the edge dithering too sharp and visible. However, I always choose none mode when my material is set to translucent. Since it doesn't use dithering but semi-transparent mask, it works fine. Feel free to test it out and find out what works for you the best. You have to set the number of temporal samples. If the anti-aliasing method is in any other mode than temporal AA or temporal super resolution, it's necessary to set a relatively high number of samples so that the image doesn't flicker. I use 64, sometimes even 128. That's why renders of this type of footage take quite a long time. If I needed to render something quickly, I would set the anti-aliasing method to temporal AA and the number of samples to, for example, 8. But in that case, I have to expect that the image will be very soft and the texture of the character will not be very detailed. I set the render warm-up count to 150. I have already explained this. Click Accept. Switch the viewport to the wireframe and start the render.